All right, everybody, welcome back. This week we're going to be looking at Boolean conditions. We're going to start here on line number 11 here. So the whole idea of programs, not just Python, but any other language, honestly, is they're going to execute from top to bottom, right? They're going to go from line 1 all the way down to however many lines of code you have, and they're going to go sequentially. They're going to execute each line, and once they hit the end of the file or the end of your program, the whole program is going to terminate. And that's probably fine for a lot of really simple things that you may want to do, like processing data, perhaps, or grabbing user input or something like that. But more than likely, you're going to want to do some conditional code, meaning you're going to want to execute some code or block a code in some situations, or you want to skip code in other situations, meaning you're going to want to be able to selectively execute some code. And that's what Boolean conditions will do for us. Okay. Okay, so here we are at line 17. So there's just a few operators that we have for us to go through and do this. And remember, or maybe you don't remember, Boolean operators, Boolean logic, or Boolean, I guess, in binary, if you remember back to our first lesson, all we know is a 0 or a 1 in binary. And that's what a Boolean operator is going to be equating for us, is we get to ask it a yes or no question or a true or false question, something that we can equate to either a 0 or a 1. So all the questions that we ask it have to have a single answer, yes or no, true or false, 0 or 1, however you want to think about it. So to ask those questions, we get a few operators. So we're starting here on line 22. I'm setting up some sample data here. So say we have a patient who's aged 39, just like me, and then we can ask it a question right here. And to do that, we have a few operators. I'm actually going to just step through this code right here and show you. Okay, so we have patient 39. And so in here we have the first one. We have this greater than sign right here. And so the computer is being asked this question. Is the age of the person greater than 39? And the answer to that should be no. So here, the answer that's false. However you want to think about it, yes or no, true or false, 0 or 1. Because the patient's not greater than 39, they're equal to 39. But you can see how by using this operator and we put a value in either side, we're asking it a question that it can answer yes or no. And so the answer or the thing it's going to be putting out is just a true or false, a Boolean value. Okay, so we're going to ask it a different question, same data. We're going to say, is the age of that patient less than 39? The answer to that again is also going to be false. Okay, so that's this less than sign. Then we have the double equal signs. Double equal is just testing for equality. Are they the same thing? It's also pretty common for people to make a mistake on this with the double equals. I was just looking down to see if yes, I do. We'll get to that in a second. So just double check that you're using the double equal sign for equality. And so now we're saying, is the age of the patient equal to 39? And for that, it should be true. And here we go. You can see that it's putting out true here in the output window. Another operator we have is this exclamation point equal. That's the syntax for not equal, meaning is the age not equal to 39? That should be false because it is equal to 39. Is it less than or equal to 39? So up here we had greater than or less than. Those both returned false. But here we have less than or greater than with the equal sign. And those should both return true because the patient is less than or equal to 39. And is the patient greater than or equal to 39? Yeah. So you can see here's all the results. And then I just summarized all the operators that we just used above. So these are all the ones you can use to test Boolean conditions. And these are really very simple examples I gave right there. We can get more complicated, which we'll go through that. We're going to start building up on that a little bit more. But in these examples, I just put them in a print statement just because I wanted to show you, the true and false output. But what you're more than likely going to want to be doing is you're going to want to be able to selectively run a block of code or skip over a block of code. And to do that, we need an if statement. And if you haven't seen ifs before from the reading or for your past experience, it's going to go look something like this. You're going to ask it a question. You're going to say if, the age is 39. And then you use this colon right here. And then you have to indent the next line. So whatever you have underneath the if condition that's indented, either with a tab or with 4 spaces, is what it's going to execute. And if that condition is true, it's going to drop down in here and print out this patient is almost old. If that value returns to false, it's going to skip over that block of code and never execute that print statement. So let's execute this here. So we go if age is equal to 39. We know that that's going to be true. So then you can see that the little yellow line, the execution of this program is right here. And it's going to put out right here, the patient is almost old. Right there at the output. Okay. So now let's show you what it looks like when we skip a block of code. So we have the same condition. We're saying, it's different. So we're saying if the patient is equal to 38, print the patient is almost old. And for all other conditions, we use this else statement, and again with a colon at the end. So we're saying if this is true, do that. Otherwise, do this. Hopefully this is making sense. So if the condition met is true, we execute whatever stuff is in here. We just have one line of code on 52, but we could have as many lines of code as we wanted. They would just have to all be underneath that if statement. They'd all have to be indented. But we know that the patient is 39, so he's not 38. So we're going to skip over that. You see how the yellow execution control jumped over that, and we skipped this line of code. And that's the whole point of if statements. We want to be able to selectively choose what gets ran and what doesn't. So then in this case, we don't say the patient is almost old because he's 38, and then we say the patient is younger or older than 38. And that's what gets printed, and you can see it right here. So I did want to show you a couple other things here. When you're doing the if and else statement, everything underneath it has to be indented, like I said before. But I did want to say in Python, you have to be consistent with how you're doing your indentation. You have two choices. You can either just hit a tab. Here, let me just write one like this. So to get the indentation, once I hit the semicolon and I hit enter, you can see that my cursor is automatically already over here and indented. If it wasn't, I could, like my cursor in 57 is not, it's over on the left. I could just hit the tab key, or I could hit 4 spaces, 1, 2, 3, 4, and that'll line up. But Python doesn't let you mix those for some reason. You can't have tabs in some cases or 4 spaces in other. You have to be consistent throughout. And it's a very sort of pernicious error because you're going to get some issues with if you have those mixed, and you're not going to really obviously notice why because it's just this white space that you can't really see. So you just want to make sure that you're careful to use the same sort of indentation throughout your whole program. And so for example, if we didn't indent this code, so let's go back up here to line 52, and we just had it underneath it like that, and let's hit save. Now you can see it turns red. Let me see go to the problems tab here. Right there. So if we go to the problems tab, it's just saying we got some invalid syntax right here on line 52. And you may not know why, obviously, or it's not an obvious error, I should say. But the whole idea here is it's complaining because you have an if condition that's empty, meaning you don't have anything indented underneath it. And Python doesn't allow you to have empty if conditions. So you'd have to indent it just like that. And then we fix that one, and so likewise our else condition is going to get the same sort of error. Click on that, because it's got to be indented. There we go. And then hit save, red goes away, and we're hunky-dory. Okay. So we've just talked about the very most basic if conditions, Boolean conditions. Again, all we're trying to do is ask a question to the computer that can be answered with a yes or no, or true or false. But when you're doing that, you have a lot of opportunity for error. You have two different types of errors that we use in computer programming. We have what are called syntactic errors, syntax errors. And that's just things where we're not following the rules of the language. And those are the things that are going to come out with the red squigglies like we saw, right? Those were syntax errors, meaning we had malformed code. We weren't following the rules, and the linter was jumping in and letting us know, highlighting things red. Those are the obvious ones, to fix because it points them out to you. So at least you have an opportunity to sort of go fix them. Those are the easy ones. The hard ones, we have a different type of error. They're called semantic errors. And those are just when our code is all hunky-dory, at least we're not getting red squigglies, our program will run, but we have logic issues in our code. And this is by far the most common types of bugs or errors that we're going to see in code. And it's where we just have bad logic that we as humans have written, and the computer's doing what you asked it to do, but you didn't ask it to do quite the right thing, so you're getting different results. And this happens a lot. So I work at Intermountain Healthcare, and we write software almost exclusively for the NICU is what I've been doing for like a decade. And anytime we get bug reports filed for our software, it's going to be because we have some sort of patient safety issue where our code did something slightly different than what the doctors wanted or are expecting, and they think it might cause patient harm. For example, the most recent one I got was the weight for the premature children was showing up in pounds rather than kilograms. And it doesn't sound like a big deal, but it is when you're coming down to like dosing or figuring out growth curve stuff or figuring out feeding schedules and stuff. And so that was, the program worked. It was showing the right weight. It's just that it was in a different unit of measure than the clinicians were expecting. And so that's sort of going to be a semantic error. We have to look for those. And those are really hard to find. Those are things you can't find unless you do a lot of testing and a lot of different data scenarios on your code to see like what all the paths are going to do. Because you see, we can skip over code or execute code. And those, when you start getting more complicated programs, there's going to be lots of branches, lots of execution paths that you can go. And in order to test all of those, you need to have a pretty robust set of test plans. And those are the ones that are really hard to track down. But the point here is syntactic errors and then semantic errors are the two types. So I wanted to show you here is a common syntax error, just like I showed you before. This is what happens when you have no indentation and it's obvious. You get the red squiggly. I'm just going to comment that back out. And then this is another syntax error. This is one I was going to tell you earlier. Hit save. So this one might look like a good, well-written line of code, 71 and 72. But it's turning red, and you may not know why. Let's go to our problem section and see what it says. Let me save my code. There we go. So we hover right there. And it may not be obvious what this issue is. You're like, I've got an if condition. I'm indenting. It should be fine. And so the difference here is we're using a single equal sign. And so this is the number one, maybe not the number one, but it's a really common issue for new programmers to make. When we're doing a if condition or Boolean logic, we're asking an yes or no question. To do that, we have to use one of those 6 or 7 signs right here, operators. And you can see we have the double equals, but we don't have a single equals. And that's what it's complaining about, is we are only using this one equal sign. And remember, from when we set up our variables, the single equal sign is assignment, just like this right here on line 22. The single equal sign means we're trying to assign a value to a variable. Instead, we should have been trying to check for the equality. So to do that, we need 2 equal signs. So they do completely different things. And it was able to catch that, the linter was. But that happens a lot. I see a lot of new programmers do that mistake. It doesn't take very long to figure out on their end that was a mistake, but just notice that, trying to give you a heads up in your own writing. Okay. So the rest of the code, I'm not going to be showing you syntax errors. I think those are obvious. They get red squigglies. But I will be looking at some semantic errors for you, just so you can sort of start to get a grasp of the idea. Everything we do in programming is going to be logic-based, and the conditions that we write matter, and the order of which we write things is going to matter greatly. And so I'm going to run through a few examples for you. Okay, and these are just slightly different, slightly more complicated, but not much. Okay, so we have a patient who's age 2, and then we're going to ask all these if conditions in a row. And so before we run this, maybe stop the video or pause the video on your side, and then look at this code, and in your mind sort of mentally evaluate each of these in your mind and try to figure out what the output is going to be here, and try to figure out what the error, or if there is an error, with this code. And so I'm going to wait a few seconds so you can on your side sort of stop and think about it. Okay, so I'm going to go and run through the code now. I was showing my wife this code the other day because, again, I've told you before, she's taken some Python courses, and I had her run through this little lecture I put together and see what her feedback was. And she was worried that we would just go through this, and you guys would just sort of have this playing in the background and wouldn't really try to think about it very hard. And so she wanted me to make sure that I said, pause the video, look through the code, see what you think, and then we would continue. So I did that at her request. But let's see. Let's jump down a little bit further. There we go. Okay, so this code might look fine to you at first glance, because we're just checking to see if the person's older than 65, they're a senior. If they're less than 65, they're an adult. If they're less than 18, they're a child. If they're less than 2, they're a toddler. That makes sense. But if you really get into it and think about it, we're going to have some issues with it, right? So let's say our patient is age 2. So we're asking, is our patient age greater than 65? Nope. So we skip over that block of code. They're not a senior. That's fine. We should all agree with that. But now we're trying to see if they're an adult. So we're saying, is the patient less than 65? And the answer is, yeah, the patient is 2. They are less than 65. So it's printing that they're an adult. And then it's saying, or asking, is the patient less than 18? Yeah, our patient is less than 18, and they're less than 2. So the output here we get, is an adult, a child, and a toddler. So the idea here is pointing out that this is a pretty obvious semantic error sort of problem here. Our code works, our logic is flawed, right? Because all we would want to do in this case is have it print out that it's a toddler. We don't want it showing that it's a child or an adult. So let's try to improve our logic there. Okay, we're going to work this through a couple more examples to build that up. But to do that, we're going to need to introduce another command called an elif. Elif is short for else if, just like we saw up here on the if and else right here. So we have if, else, and then there's another one called elif, which is an else if, right? Let's get rid of that. Right here. So here on 98, you can see the elif. What the elif does is it enforces mutual exclusivity right here, talking about that. So when we have if statements chained or linked with these elifs, they all become mutual exclusivity sort of checkers, meaning the execution of the program is going to go through and it's going to look for the very first condition that it matches, and then it's going to print that out, or it's going to execute that block of code, and then it's going to skip all the others, meaning only one of these blocks of code can be executed, and it's going to just match the very first one that it can find, right? So right here, the first one that matches on is the one that it's going to use, and then it's going to skip all the others. So that should get us a little bit better. All right, so we're saying, is the patient greater than or equal to 65? Nope. And then we're saying else if the patient is less than or equal to 65. And yeah, but, so we still have a flaw because we don't really want it to show a patient because it's a toddler, but it's not going to show the child or toddler. You can see it only put out the adult, which is an improvement, right? It's only executed this one instead of those other two, those three in combination, because we put this elif on there, and it says, all right, I found one of them that matches. I'm going to skip all the others and just exit this whole block of code here. So it's slightly improved, right? We're only getting one output instead of all three of those. So the next thing we can do to improve our code is we were taking what we just did up there above, and then we're thinking logically in our own mind, right? Order matters when we do things, right? Just like in the real world, and it does in programming. So let's rewrite this, but all we're going to do is we're going to switch the conditions, right? We're going to, instead of starting with the highest numbers at the top, 65, 65, 18, and 2, we're going to invert that. We're going to say, put the smallest numbers at the top, 2, 18, 65. And let's see what that does for us. So now we're going to say if the patient is less than or equal to 2, oh, yep, he's a toddler. And then, because these are all mutually exclusive, it's going to skip over all those other ones. See, now we got the proper output. Okay. So I just wanted to show that this was a couple of different ways that we can improve our code and this logic to get us the proper result. But we can still go a little bit further. We can make it a little bit better by having more robust conditions. You can see here we're just asking a single question. If the age is greater than or equal to 65, that gives a huge range available to it, right? Everything greater than 65 is massive. Everything less than 65 is also pretty big. What if we wanted to have more tight conditions? And we can do that, but we need to introduce a couple more words that we can use here in Boolean. So we have the ands, the ors, and the nots. And these are just like you would imagine them to be. We can ask a couple of conditions, and we separate them with the ands. And what will happen here is just like you can imagine, if both conditions are true, right here. So if both conditions are true, then your and condition is going to be true. And then on the or, if one of the conditions are true, it's going to return true. And then all the not does is it inverts the answer. So whatever question you ask it, and if you put the not in front of it, it's just going to invert that. So if you ask it a question that's true, and you have the not sign on it, it's going to make it a false. And not kinds are a little confusing. I know my wife struggled with this a little bit when we went through it the other night. And not a lot of people use nots, or at least not beginner programmers. They can, obviously, but it's just extra confusion. But I just want to show you a couple of examples just to show you what that means. So here on lines 127, 129, I have a little block of code. I'm asking the exact same question. I'm saying if the age is greater than or is equal to 0, right there, and then again right here, age greater than or equal to 0. So the exact same conditions, it's just that one of them has the keyword not in front of it. So all the not does is it inverts whatever the answer is right here. So again, the age of our person is 2. I'm hovering over the age to show you. Right there, it's 2. So if the age is greater than or equal to 0, which it is, but then I have the not in front of it, so it's going to make it a false. So it skips that block of code, and then it executes this block of code. So I don't know if that's confusing, but this should have been a true, but the not in front of it says, no, I'm going to invert that for you and make that a false. And there's lots of reasons you might want to do that. Most beginners don't really use that typically, so you don't have to use that. You can just write your questions differently, right? You could have said, if the age is greater than or is equal to 0, or if it's less than 0, right? So if you just want to try to find out if it's a negative number, you could say if age is less than 0, and then it should be a negative number. So this is a little bit more convoluted. I just wanted to show you using the not statement. Okay, so let's look at using the and statement. And we'll stick with our same example. We're going to try and build it up to make it a little bit more robust. Okay. So what we have here is we can ask 2 questions or multiple questions, and we separate it with the and. So just like we were doing up here, we could only ask it 1 question at a time. The and statement lets us ask multiple questions at a time and just separate them with the and, right? So we're saying if the patient is greater than or equal to 18 and the patient's age is less than 65. So if both of those things are true, then it must be an adult. Do you see? And then we're saying right here the same thing. If the patient is between 2 and 18, then it must be a child. And if it's less than, it's a toddler. Older than, it's a senior. So we're able to simplify our logic or make it more robust and certain using the and condition. Okay. So let's see what we get here. So we execute through. So is the age greater than 18? Nope. Is it less than 85? Yeah, it is less than 85. because we have a patient age of 2, but that doesn't matter because both conditions weren't met. Now we're saying, is the age greater than or equal to 2 and less than or equal to 18? So yeah, it should be true. Yeah, and so it prints child and then skips over toddler. So that one worked, right? We got a little bit better logic going on in there. Okay, so it's the exact same code. So I just copied that block of code. I put it here, and all I did is I replaced the ands with the ors, just to show you how the ors work. And so with the ands, scroll back up here to show you, with the ands, both the questions, or the questions it asks on either side, the left side and the right side of the and statement, they have to both be true in order for it to be true. The ors only require one of those conditions on the left or the right to be true. And if either one of them are true, then it will return a true. Right, so in this case here, we ask the question, is the patient age greater than 18, which it's not, because it's 2, and is the age less than 65? It was less than 65, remember, because the patient is 2. But because it's an and, this question had to be true and this question had to be true in order for it to go down here into this block of code. And they weren't. So now when we go here with the or, we got the same sort of thing going on. So we're saying, is the patient age greater than 18? Nope, it's not. Or, that's the difference, or is it less than 65? And yeah, it is, right? 2 is less than 65. So it went in here and said, oh, it's an adult. See, so we're starting to introduce some errors again. These are semantic errors this time, right? Logic errors. And then we're saying, is it greater than or equal to 2? And yes, it is. So it's going to print out adult and child. Right, so we introduced some issues with our code there by using the ors. So it's just important to know the difference between the ands and the ors. And I don't have an example of this, but I just wanted to make sure you know you can link or chain as many of those together as you want. We can say, is the patient age greater than or equal to 2 and age less than or equal to, 6, and this is what I'm trying to say, right? You can do as many of these as you want. This logic doesn't make sense. I'm just trying to show that you can do as many of these things as you want. And obviously this condition will never be true. This is a ridiculous thing to write. But I'm just trying to show you that you can write these as much as you want. And it's going to just evaluate what's on the left and what's on the right. And if you want to group things, so my wife was asking us the other day, this is why I mentioned it. She was saying, what would you do if you wanted to ask for 2 conditions to be true or a different condition to be true? So you can group them with parentheses. So I can say, are those 3 things true, this and this and this, or that? And by using parentheses, right, I'm saying evaluate everything in that parenthesis block. All of that has to be true, or this one thing has to be true. And so you can get as complicated as you want. And there are, believe me, there's plenty of complicated lines of code out there that do just that. But I just want to make sure you knew that you could nest those, or chain those things together as deeply as you want. Okay, the other thing I wanted to show you, again, this came from my wife. This wasn't obvious, I think, to her, is that you can, when you're debugging your code, meaning you hit one of these little red circles, and then you hit the F5 right here, the start debugging, which is what I've been doing this whole time. When you do that, you can see that we've been using this sort of terminal thing to see what the output is, what all the print statements are. But there's this thing called a debug console, which is very similar to the terminal, except the difference is it has this little blinking cursor down here. And this blinking cursor lets you type in some Python code, and it uses all those specific variables that are currently in memory, and it lets you sort of test and see what some of that code is. So you can see what your code is going to evaluate before it does. So for example, I don't know if my patient, or I do know, right? Age is 2, and is it less than 65? We don't know. We do in this case, but imagine it's something a little bit more complicated and we don't know what the answer is going to be. We can just go down here into this little line of code, type in age less than 65, and then it shows you what the result will be from that. Or if you don't want to do any typing, or if you want to just get something more complicated like this, you're like, what's all that going to be? You can select it like the, oops, I missed a thing there. You can select it all with your cursor. And there, you can hit right click, and then, where is it? Debug evaluate. click this debug evaluate, and it'll just copy and paste it down here for you and then execute it and give you the response. So this is really helpful if when you're running the program, whatever value in this age might be different, or you may not be quite sure how all of these things combined together are going to evaluate, and just doing that will help you figure it out. Or you can hover over stuff, right? Age is 2, and then just hit your F10, right? That's this button right here, F10, step over, and this little yellow line will go over. So I just wanted to show this to you, that you have the opportunity to sort of check your variables. And it's all these things over here on the left, right? This is what I'm talking about. Oops. These are all the variables that are currently in memory. Right now it's just age. This other stuff is system stuff that we don't need to worry about. But we have just age. And so it's going to take whatever variable and values are there and go do the evaluation on it that you have asked it to do. Okay, so that was this part right here. If conditions, we can also nest our if conditions to start to get some complicated logic. And this is extremely common in the real world because most conditions are extremely complicated, especially in hospital settings, and I'm sure everywhere else. So let's look at this block of code. Or as my wife would say, why don't you pause the video for a second and sort of try to look at this with your own mind and sort of think what's going to happen, right? So if we have an age of 2, look through this and see what you think is going to happen. What is the output going to be from this? I'll stop for a second so you can do that, or just hit pause. Okay. Okay, so we have some conditions that they're nested, right? So we have this if statement, and then indented we ask another if and elif block, and then we have this outer elif and if block. Okay, so it's a little bit more complicated, not a ton. We're just working up. We're trying to get our if skills stronger. So if we have a patient who's greater than 18, nope, and less than 65, yes. So that's a false and that's a true, but the and is saying they have to both be true. So it's going to skip this whole block of code, right? It skipped all of that, just like we would expect it to. Now it's going to ask on their elif, is our age greater than 2? Nope, it's not. It's equal to 2. And is the age less than 18? Yes, it is. So our output's going to be nothing. So that's a little bit of a trick question, right? I was just seeing if you can follow through that with your mind. So it doesn't output anything. In order to change this code so that it did do something, we would have to do that. We would have to change our logic to be a little bit better. Let's just run that again. Okay, so we're saying, we already know the answer to this, right? It is less than 65, but it's not greater than 18, so it's going to skip over that. And now we have, is our patient's age greater than or equal to 2? Yes, it is. And is it less than or equal to 218? Yes, it is. So now we're going to come into this block of code and do something. And now we're just looking to see if they're a tween, which they're not. So everything else, we're just going to say they're a juvenile, right? Because we know they're between 2 and 18. We're trying to further subdivide them into tweens or whatever. And the default answer, that's what the else is saying, right? So in pretty much every other case, you're a juvenile. And that's what we print out here. Okay. There's a different way. This is the most common way. This is the way that most people are taught to write logics with the ands and the ors and the nots. But Python does have another snazzy little way if this makes more sense to you. So the way you would write it in mathematics. So it might be more precise and more, I don't know. We're writing it this way, that this is Python's chaining these things together. These operators, this less than or equal to, greater than equal to, equal or not equal, those operators. We can start chaining those by putting these things in sort of this range notation that you would do in math, right? So we're saying, is age greater than 18 and less than 65? So we wrote all the same logic. We just got rid of the ands and the ors, right? So I literally took this exact same block of code, right? I took all of this code. Oops. I copied all of this code, but I just rewrote it to get rid of the ands or ors, whatever were there. and slightly different, right? So we're saying if age is between 18 and 65, and then if it's between 2 and 18. So it's written slightly different. Hopefully you can see that. There's no ands and ors in here. This is sort of the chained math notation that we would normally have. And it gives us the exact same output, juvenile. So if looking at this style of writing those conditions makes more sense to you, then you're obviously welcome to do it. Most people choose not to. They prefer the more verbose ands and ors and nots and things. Just wanted to show you that you have options. Okay, I also wanted to make sure all these if conditions I did were pretty simple, right? We're just checking if one number is greater than or smaller than another number. But I wanted to say, you don't have to just do that, right? We have all these like methods and libraries of code that are doing things for us, and we can check those on our if conditions as well. I just want to make sure we're not sort of boxing ourselves into a hole or whatever with that basic sort of Boolean logic I was showing you. You can do a lot more complicated things. So for this example, if you haven't seen it before, this len is a method that Python gives us for free. And anytime you have a method, you have to use parentheses to pass a parameter to it. So we're saying len means length. You can hover over it and it'll tell you these things. Or if you start the parentheses, right there, it'll tell you. The length object, and it will return the number of items that are in a container. And for the parameter, we give it an object, right? So it's saying, here's a method called length. It's expecting you to give it a parameter called object, and then it will return you a number of how many items are in that container. So you remember from our data types lecture that a string, like this one I've done here, this string name of Chad, a string is just a collection of characters, meaning there's 4 characters in there. So I'm saying, go grab the length of name, and whatever the result of that is, I'm going to do some operations on it, right? I'm going to say, if it's less than or equal to 4, you've got a short name. And I could also say if it's greater than 10, you have a long name, or whatever. It's a silly example, but I'm just showing you, you can use the output of methods also, right? So if I come here, and this is also what you can do if you don't, this is kind of what I was trying to show the debug evaluate for, right? I can highlight that, I can right click it, debug evaluate that, and it shows you right here, right? The length of name is going to be 4. And so I'm saying if it's less than or equal to 4, you've got a short name. So Chad is a short name according to this logic. See that? Okay. Or here's a different one. Let's say we have a list. That's what lab results are, is a list of these items, however many there are. 11 items, it looks like. Right there, all of those. And then we can go ask questions on that, right? Same thing. What's the length of it? So say we have an example piece of logic we need in our code, just saying, are there any lab results for a specific test? Meaning, I don't know. I always go to the diabetes, right? Has somebody had lab results logged for the hemoglobin A1C? And then we don't care what the values are. We just want to see if there are any at all, right? And then we might want to do something different. And so we're just saying, as long as the length of this lab results array for hemoglobin is greater than 0, we're going to do something, right? We have lab results. And likewise, if this was an empty array or an empty list, it would have skipped that block of code. And here's a slightly different one just to show you. We don't have to just keep using length, but there's another one you can get. So since we're using the list here, the lab results list, we can use this dot notation. If you haven't used the dot notation, only a few things can do it. Only objects can do this. And we haven't talked about objects in our class yet, so I don't want you to get hung up on this until we do get to objects. But I can hit the period. Let's call this the dot notation, right? So I go lab results as a list. I hit the period after it, the dot. And then it shows me all the options I can do to it, all these methods that exist. You pretty much want to skip anything with these double underscores. You want to just stick above that. These are system things. These are user things. But I can do a lot of stuff to it. One of the things I can do is I can do a count, which is this guy right here. And then if I do the parentheses on count, it says you give it a value in the parentheses, and it will return you the number of occurrences of that value. So I wanted to look for 1. Let's say we have all of our hemoglobin A1C scores, and we want to count how many times there was a result value of 1. That's obviously not a very good score for hemoglobin. But I'm saying, count me and give me the number of how many times 1 is in that list. And so we're looking up here at this list. And how many times do we have it? 1, 2, 3, right? And we can confirm that. We can select that block of code, right-click it, debug, evaluate. I'm just going to copy it down here. And hit enter. And sure enough, it gives us 3. It says, oh, there's 3 number 1s in there. And so all I want to know is if it's happening more than once. And if it does, then we print it. Hopefully that's making sense. Okay. So that's going to end it for the Boolean logic. That was a pretty quick intro to it. But I want to leave you just by saying the whole point of the if statements are we're going to have some chunks of code that we want to execute in certain conditions and other chunks of code we want to skip in other conditions, right? So we want to be able to have our execution jump around a little bit or skip things. And so the next question in the next video will be, what do we do when we want to execute code or a block of code multiple times over and over and over again? And that'll be the topic of the next video. So I'm going to stop this recording now, and then you guys